Hi, in this talk I chose to discuss spatial cognition and its application to navigation systems design. My background is urban design, and I chose this research because I'm interested in topics related to visualization of spatial data. I'm going to focus on understanding spatial cognition processes that are similar to users whether applied on a large scale, such as streets, districts, parks, or small scale, buildings and gardens. And design principles can help to improve these processes and reduce disorientation. To understand navigational needs, I'd like to emphasize the difference between wayfinding and navigation. Wayfinding is a knowledge-based behavior. It relies on an existing understanding of an environment. This understanding comes from spatial knowledge gathered from previous experiences, maps, or verbal descriptions. The quality of wayfinding depends on nature of experience and the complexity of the environment. For instance, some experienced taxi drivers show amazing ability to wayfind, relying on extensive experience-based spatial mental model. This ability is consistently higher than average not only in familiar environments, but also in new places. In contrast to wayfinding, navigation is a skill-based behavior. Navigation doesn't require use of spatial representations. Rather, it requires an understanding of how a sequence of procedures should be used. Compared with wayfinding, navigation is more passive and less complex. A person follows a prescribed series of turns and distances, rather than derives. But even though navigation appears to be simple compared with wayfinding, the design of technology to aid navigation is very complex. Difficulties in design arise from at least three issues. First, dynamic user tasks and goals. A designer of the navigation system needs to address questions related to how to present information that can be adapted to different user goals. For instance, surveillance the city as opposed to moving between landmarks. Second, another issue is different user experience and different memories of environment. Navigation system design has to address needs of both experienced and inexperienced users. This includes elimination of irrelevant information and reduction in cognitive load. Another problem that navigation systems address derives from very complex environments. Environments are different in many ways, such as landmark size, path network, topography. In general, the higher the complexity, the more details are necessary to navigate. But on the other hand, more details mean higher cognitive load. Navigation systems need to have the right balance of information shown. There are at least two forms of mental representations responsible for navigation behaviors: spatial mental models and cognitive collages. Spatial mental models apply to memory maps created from reading descriptions about environment or understanding verbal commands. Another form of spatial memory is constructed cognitive map. Researchers have proposed that the cognitive map is more like a collage. It's layered, overlapping, and three-dimensional map of information. This information can either relate to space or include images, sounds, verbal descriptions, or even smells. These mental representations can be distorted. They widely depend on orientation, perspective, proximity of user to landmark, and many other non-spatial factors. Here we need technology aid. So, how our knowledge of human cognitive mechanisms help to design a navigation system? First, navigational aids should use multimedia. It proves to be the most effective to present information both visually and verbally. Navigation systems should use maps for spatial information and use verbal information to label landmarks and describe current or upcoming actions. The cognitive mechanisms behind the multimedia use include dual coding and generative processing theories. Dual coding theory talks about simultaneous and independent processing of verbal and image information. Therefore, we maximize our working memory resources when information combines verbal and image formats. The generation effect theory says that actively selecting and integrating information from multiple sources can itself help to improve memory. Second, for navigation and wayfinding, availability of local information as well as global information is critical and depends on map details. When we design navigation systems, detailing of the map should depend on the environment and current navigation goal. Let's take the following example. Person A just moved to a new city and wants to drive around, so he can start construct the basis for wayfinding. Person B came to a new city for a conference and needs directions to an hotel. Person C runs errands and needs to make stops in several locations. These three people have different navigational goals. Therefore, the spatial information format also differs. First person's goal would be best served with the bird's eye map that highlights landmark of interest to guide his route. The map should change as he approaches the landmark and combine verbal labels. Second person's goal can be served by combining a dynamically updated route, action commands and decision points, and estimates of remaining trip time. Third person multiple destination goal would need to combine the two previous formats. The bird eye map would highlight destinations and their relative locations. And the dynamic route map with the action commands would guide travel between destinations. In summary, based on many factors, multimedia navigation is the most effective. However, it is designer's responsibility to allocate information to right format and decide on level of detail included in each format. Researchers came up with the following design guidelines for navigation systems. More is not better, because graphic simplification in maps helps to reduce cognitive load and frees up mental resources to process, store, and recall more information overall. Designers are responsible to allocate information to visual and verbal formats. User navigation goals are important when design combined multimedia assistance. Thank you.